In section 6.5, we're going to talk about analyzing and sketching graphs. So this is your key idea today. Graphs can show the relationship between quantities without using specific numbers on the axes. So if you look at your graph here, which I do want you to write down, this graph is relating distance and time. So as time goes on, the distance is either increasing, which means the line is going up, no change, which means it's constant, or the distance is decreasing. Example 1. The graphs show the temperatures throughout the day in two cities. One graph represents Belfast, Maine, and one graph represents Newport, Oregon. So what I want you to do is sketch these two graphs. Now, part A, we have to describe the change in temperature in each city. This is not something where you're just going to write one sentence and be done. So you have to make sure you take the time and realize what's happening. Well, if you look at Belfast, look at it. As the time never stops, by the way. Your x-axis here, it will never stop. This continues on. So what happens? At the beginning of the day, the temperature increases. Then the temperature begins to decrease. Right here, decrease, 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 at a faster and faster rate for the rest of the day. So it goes up, slows down, it increases, and now it starts to decrease. So we have to write that down. For Newport, Oregon, if you notice your graph, it starts, the temperature decreases at a constant rate at the beginning of the day. Then the temperature stays constant before increasing for the rest of the day. So then you would need to write that down, that the temp decreases at the beginning of the day, then the temp stays constant for a while, and then increases for the rest of the day. But we're not done with this problem yet, because part B says, make 3 comparisons from the graph. Now, these are only possibilities, so you don't have to have exactly these 3, but I'm going to make 3 separate comparisons. So 3 things I've compared here would be, the first one, both graphs show increasing and decreasing temperatures. Both graphs are nonlinear. In Belfast, it was warmer at the end of the day than at the beginning. What I mean by that is if you look at your arc, it starts lower than when it ends. It ends a little higher, so that means it was warmer at the end of the day. In Newport, though, it was colder at the end of the day than at the beginning. All right, so in example 2, we have to sketch a graph that represents each situation. So part A says, a stopped subway train gains speed at a constant rate until it reaches its maximum speed. It travels at this speed for a while and then slows down at a constant rate until coming to a stop. So let's first draw our axes. This is going to be time. And since we're talking about speed, speed is going to be your vertical axis. So let's start by looking at the first sentence. A stopped subway train gains speed at a constant rate. So we're right here. It increases at a constant rate. Until it reaches its maximum speed, it travels at this speed for a while. So the speed no longer increases. So at constant rate means it goes up at the same rate. Then the speed stays here for a while. So the speed does not increase anymore. Then the speed slows down. So it slows down until coming to a stop. So then it slows down at a constant rate until coming to a stop. So that would be the graph that represents this problem. B, same thing, sketch a graph. As television size increases, the price increases at an increasing rate. So, as television size increases, so this is going to be TV size, the price increases. So the price will be your vertical axis. So let's start graphing this. A television size increases. So as the TV size increases, the price increases. Well, the price doesn't start at 0, 0, so we're going to start it, let's say right here. The price increases. But then it says at an increasing rate, so it doesn't stay constant. It keeps increasing as the TV size gets bigger. So your line would look something like that. And actually it's not a line, but your graph would look kind of like a curve going upward because it increases as it goes. It doesn't remain at a constant rate. A constant rate would always maintain a linear line. So a linear graph would be a constant rate. This is not, therefore it increases as the TV size increases.